Equilateral triangle. Many practical problems involve triangles. Now we will apply Pythagoras theorem to equilateral triangle. Equilateral triangles have sides of all equal length and angles of 60 degrees. To find the area, we can first find the height. To find the height, we can draw an altitude to one of the sides in order to split the triangle into two equal right triangles. Now we apply the Pythagoras theorem to find the height. Pay attention. Given the height, we can now find the area of the triangle using the basic equation to find the area of triangles. Now, we put the value of height in the area of the triangle equation and simplify. This is the formula. Let's see how it works. Find the area of the height and the height of the following triangle. Take the formula, substitute the value of one side and simplify. To find the area, take the formula and substitute the value of one side and simplify. Regular hexagon. It is also worth noting that 6 congruent equilateral triangles can be arranged to form a regular hexagon, making several properties of regular hexagons easily discoverable as well. The measure of the interior angle of a regular hexagon is 120 degrees. The measure of the central angle of a regular hexagon is 60 degrees. Therefore, a regular hexagon is made up of 6 equilateral triangles. To find the area of a regular hexagon, take the formula to find the area of an equilateral triangle and multiply it by 6. And simplify. Let's see how it works. Find the area of the following hexagon. This is a regular hexagon. Take the formula, substitute the value of one side, and simplify.